Thanks for joining us again on the HVAC School podcast, Jim.
It's my pleasure, Bryan. Thanks for having me.
It's always good to have you, and you're looking fresh, and you also are going to be able to show us on the video version of this, which we are going to do in addition to the podcast. So look out for that. He's actually got this cool camera thing that I'm really excited to have you use, so we can see inside of the SureSwitch. Just start with the high level, because everybody who, when you start in school, you're an apprentice, you start messing with contactors and relays. And those designs have been pretty much the same for as long as any of us have done it. And so what is the reason why we're innovating? So SureSwitch is a significant innovation, but what are the reasons why we're making this innovation?
The reason why we're making it is because we're innovating forward now, for the fact that before we were in the industry did renovate backwards a little bit. When these ACs first came out, we go back in the 60s, before our grandparents were not grandparents. And at that point in time, the contractors in these things were like Sherman tanks. They were built super heavy duty. And as with everything in manufacturing, you get your manufacturers that say, hey, how can we improve the cost? And contactors were lightened up. And actually, when we would have started in the trade, they were still 2-pole contactors. We actually broke both sides. And again, manufacturers are saying, hey, we're needing to cut our cost here a little bit more. And then we go to a 1.5-pole contactor, which is a set of contact points and a shunt on the other side. And that's pretty much across the board what we're seeing out there in the field today. And the 2 would work, the 1.5 would work. And so that's one of the things we talk about with the SureSwitch is you can use the SureSwitch, which is a 1.5, to replace a 2-pole contactor. As long as you're breaking one of the 2 legs, your motors are not going to run. So the taking and making a contactor a lot smaller or with less parts was the going backwards. And here we are with SureSwitch taking this and moving it all the way forward beyond what the original heavy duty contactors were. The SureSwitch, with all of its electronics and ability to think, takes contactors to the next level.
Yeah, for sure. So one of the biggest things that it does right off the bat, and I really like this because this is something that really applies to my business and a lot of small businesses out there, is it gives you the ability to have one contactor that does a huge range of different applications because of the multi-voltage, the multiple coil voltage. And that's a key distinction. When we're talking about the multi-voltage, we're saying that it has multiple coil voltages. Obviously, the contact points are going to be rated, for kind of your standard 120 through 240 volt, the actual points themselves. But the voltage that drives the coil, that's very unique. And to my knowledge, there's not another contactor out there that's going to have that level of flexibility.
Correct. Yeah, all of your standard contactors at this point, there's only one voltage you can put to the coil. If you do try to put 220 or 110 to a 24 volt coil, you let a lot of smoke out of that coil. It won't keep it in. Yeah.
It's hard to get it back in once you let it out.
It really is.
Timers taught me.
Yeah. So the idea is to keep the smoke in. And with the SureSwitch, you don't have to worry about any smoke escaping, because it has terminals on there that you can do the 24 or the 110 or the 240 on the coil. The actual contactor voltage we rate as 110 or 220, but also as single phase. So that's your coil voltage, which is going to be the same on all contactors across the board of similar size and rating.
Yeah, so that makes it easy. Now, again, you did make a very important distinction. When we say that it's good for everything, we're saying all single-phase applications here. Obviously, You would not want to just break one leg of a 3-phase application. That would be no bueno. But so you're talking about, condensing units for refrigeration, obviously typical residential HVAC, reaching cases, ice machines, a wide range of different applications. For us, pool heaters, because we do run into some pool heaters that have 240-volt coils on them. Just a couple goofy brands out there that do that, but it's nice to have one contactor that can serve all of those purposes. So that's one thing. It's just reducing the number of SKUs that you have to have. This helps you do that. A lot of the listeners out there are only doing residential, and of course, it does a really good job of that too. But it just gives you that flexibility.
Yeah, that's the idea behind it, and I think you're right. The majority application is the residential HVAC.
All right, so let's get into one of the most fun parts of this contactor, though. And this is going to give you a chance to use your fancy camera and show us. If you're on a podcast, you're just going to miss out on this, the audio only. So let's talk about how this contactor lasts so much longer. There's some really dramatic pictures that we'll kind of throw up as well that show how traditional contactors look after 300,000 cycles versus how the SureSwitch looks after 1 million cycles. And, just to kind of give away the lead here, the answer is traditional contactors look real bad and SureSwitch looks real clean and shiny still. Talk about why that is. What's different about SureSwitch that allows it to last so long?
So it may be a specific image that, and if you don't have one, I can share it with you to put up, that actually shows this little black bead or this little eye that's clear in the bottom of a sealed box. And that little eye is a light sensor. And that's all we're doing is looking for light, looking for an arc when the contact points open and close. And you get it just as much in the opening as you do in the closing. But the opening, if you have that voltage present when those contacts open, you're going to get an electrical arc. That electrical arc of light is what starts damaging and starts pitting the inside of those the contactor, the points in that. And so let's see if we can get this split screen here to come up and get things in focus here. This is the inside of a SureSwitch. I have a cutaway view here for our actual SureSwitch for those listening in, and the top of the SureSwitch is cut open so you can actually see down inside the SureSwitch. The contact points, which you can see right underneath inside this box. This is really tricky to look at something on a screen. I would never make a surgeon because I would be going for the liver instead of the colon.
It's the opposite. See, you're being negative. You say you would never make a surgeon, but after this, you will be able to start your career in surgery.
Oh, yeah. I didn't think about that. Yeah,
you're practicing, yeah.
Because this is the colon, the liver's over. No, I'm sorry. This is the contact points. And underneath the contact points here, if we was to get way up in there, and I don't think we can, but there is a little black dot underneath those points. And that's what, with that light sensor, when these contact points open and close, which up at the top I can pull and push, they're closed now, and then go the other way, they're open. You can see them opened up there. With that, that light sensor is looking at the time it switches, where it is at in the sine wave of 60 hertz per second, which is our alternating current sine wave. That means that it's going positive 120 volts to negative 120 volts in one cycle 60 times every second, positive, negative. And in that sine wave, it's crossing between positive 120 and negative 120. Right in the middle is 0. That means 0 volts. And so our microprocessor, which is a board, an electronic board that sits inside the SureSwitch, is looking at that sine wave. And it's saying, did it see light? Yes. It has to be at the top or bottom of the sine wave where there is a high amount of voltage present. Whenever it sees that, it will adjust itself on the sine wave until the light disappears. And it knows at that point that it's in what we call the no arc zone, or where it's crossing 0 in the sine wave. And when the contact points open right at that 1/60th of a second, or 1/30th of a second, if it's crossing more than once here in that 60 seconds, that is where the contact points open. No arc, no spark, no pitting of the contact points. And now we have contact points that are lasting 5 times as long.
Yeah, it makes perfect sense. And one of the things that I think, because it seems like magic, like how on earth does it do this? Well, once it figures it out once, it's not like that changes. Right? Like it's not like all of a sudden the power company is going to change the point in the cycle rate. So once it figures it out and kind of gets dialed in, it can just stay right there. And
Yes.
that's a pretty neat thing, because again, the only reason it needs to do that at all is because the contactor doesn't know when you installed it, like when you first powered it on, so it has to figure that out, and it uses that eye to do that. And that really is the secret sauce for that sort of operational longevity of the
Mm-hmm.
contact points. The reason why they last effectively forever, because if they still look clean and shiny at a million cycles, that means that it's designed to last for a really long time. But now also talk about the other cause of contact failure, which is chatter, and how this
Mm-hmm.
SureSwitch deals with that.
So one final piece of that electric eye, it doesn't say, okay, it's in the 0 arc zone and then shuts that part of the circuitry off.
Right.
It continues to monitor that, because if you do have a situation where you've got a power outage, disconnects pulled, there's no voltage going to the SureSwitch. At that point, when it's powered back up, then it's going to be looking again, and it doesn't say, "Oh, there's light here. I know exactly where I'm at." It's taking a couple openings to get to that point, but it's not enough that you're seeing any damage to those contact points. Not like when the contacts don't have, and let's say not the contacts, back up, beep beep, back and go to the point of the coil. Now on standard contactors, you have a coil that requires 24 volts to have enough power to pull the contactor down and close the contact points. If you do not have that full 24 volts, if it's weak, it's pulling down at the same time. The spring that's pushing the contact points away is pushing against it, and it opens and closes multiple times within a few seconds there, in what we call chattering.
Yeah, and
Chattering is,
we see chatter for a lot of reasons. I mean, you mentioned
yeah.
it, low voltage, and that can happen because we see a lot of times technicians forget to tap the transformers when it's at 208 applications. They forget to retap them. But then in our
Mm-hmm.
market, we'll see these brownout events. And like, I don't know what it is about where I live, but it happens all the time where you see the lights dimming. And that's a case where you'll get massive damage to contactors. I almost said contractors too,
Yeah.
to contactors due to those voltage drops.
Correct. So multiple reasons why we have that. That is a very valid application out there in the field. Another time that occurs, the gauge of the 2-conductor wire going from the indoor to the outdoor is too light. Typically, you're going to see a recommendation of at least 18 gauge 2-conductor wire to go to that outdoor condenser. If you're lighter than that, if you're 20, 22 gauge, that light wire doesn't have the ability to carry that 24 volts. The other time that can occur, even with 18 gauge wire, is you have an extremely long line set. And now you're carrying that 24 volts 60, 70, 80 feet. I hesitate to say 100 and 125 feet, although I know those systems out there exist. And especially in high-end homes where the homeowner is saying, hey, I want this condenser behind the fence on the other side of those bushes, clear away from the house. And when those types of applications, you got long line sets. Recommended? No. You read your installation instructions, and your manufacturer is going to give you a limit well under 100 feet for a line set. But the reality is, on occasion, it does happen. And with that happening and that long 2-conductor wire, you have voltage drop again because of the length. And all of that voltage drop just simply means you're not getting that full 24 volts to the contactor. And without that full voltage, now the coil magnetic pole is fighting against that spring, and you're opening and closing, you're getting a lot of chatter.
So in the SureSwitch, we have latching capabilities. Talk about that. How does that work?
Correct. So in the locking capabilities or latching in the contact points themselves here, and let's get up close to the camera for those of you who are watching. There is in the middle of this sealed blue box, which I have taken the top off of this box. There is another piece here, a little white plate. Underneath that white plate, there is a small magnet in there, and a piece in there that will go against that magnet to hold it, or repel against that magnet to pull it apart. And so that is what we call the latching mechanism. Whenever the coil in the contact points here is energized, and by the way, it's not energized with the 24 volts from the 2-conductor wire going to it, or if it happens not just to be 24 volts, it happens to be 120 or 240 volts. That voltage is going to the board to tell the board there's voltage present. Let's send the 24 volts that's built into the SureSwitch to close this coil, and that way the contact points in here are latched open or latched closed. And once they're latched closed, they are not chattering. So we've completely eliminated that chattering. One more application there is, and we will just keep it generic and say another brand of thermostats that are on the market right now, that the relay in that thermostat is not allowing the full voltage through, and we're seeing a lot of chattering coming from that brand of thermostats. And so if that is an absolute must for the homeowner, then the SureSwitch is a must to save the contact points. The most ideal would be to replace the contactor that has been arced and pitted with the SureSwitch, but maybe even upgrade the thermostat to one of our nice Sensi Touch 2 Wi-Fi touchscreen thermostats.
I like how you slipped that in. That was good. That was smooth.
And the complaint would be, oh no, we can't. We only got 4 wires to connect to the thermostat, and you have to have 5. You have to have a common. Well, here's your next plug. The Sensi EIM equipment interface module now allows you to run 2 wires, 24 volts in common, to the touchscreen thermostat and communicate through radio frequency. And all of your wire connections are now at the indoor unit, so that you don't have to worry about having that common wire anymore. So we've closed the points on this. I think we've closed all points, and if we aren't careful. Yes. If we aren't careful, we are going to go back to chattering. So, yeah, this is...
That is true. We're the ones you have to worry about chattering, not the SureSwitch. That's for sure. That's for sure. Yeah, very cool. So, all right, we've covered a couple things here. I want to make sure that we're doing them one at a time. So, one, the contacts last a really long time because they close and open at that 0 point, reducing that arc or eliminating that arc eventually. Once it kind of learns and figures out the sweet spot. You also have the latching contacts that ensure that you're not going to be prone to chattering due to brownout conditions, due to undersized wire, all this. And like you said, because the SureSwitch is using its power supply that's coming right from the high voltage, it's generating its own power supply in order to bring in that contact. It doesn't rely on that potentially weakened signal that's coming down the line, which just makes obvious sense. The other thing is that it's completely sealed. So talk about that, because I think that's actually one of the biggest factors in terms of the longevity of the contactor.
Yeah, so there are applications where ants decide to take up residence in a outdoor condensing unit. You know, if you have 5 ants that decide to move in this contactor or condensing unit, and they call 5 more ants into the condenser, all of a sudden you got tenants.
10 ants.
10 ants. You have 10 ants. Yeah. And so when you have 10 ants in your contactor or your condenser, one of them is going to find their way inside the contact points and bravely give itself for the benefit of everybody else, so that the unit quits functioning. Unfortunately, there's heat with this, and the ants are drawn to heat. And what I like to say too is, when you have insect pressure, if it's earwigs, ants, in Florida, we actually had a comment that I thought was interesting. They are not calling this SureSwitch a ant saver; they're calling it a lizard saver.
Yeah, indeed. Yeah, lizards are bad down here.
So we don't have the issues of lizards. So it can be lizards, it can be ants, it can be earwigs, lots of things. And if you go and take out a contactor and put the same contactor back in and expect different results by putting the same thing back in, and I think you have a saying for that, if I remember right.
Yeah, pretty sure that's the definition of insanity. Yeah.
Yep. Yeah, and so you have an option of saying, okay, homeowner, let's get a pest control company out here, and let's get these 10 ants kicked out. Or if you don't, you're gonna end up having an additional problem, and that's where the 100% sealed contacts with this little blue box in here, and there is a blue lid or a blue cover on here. I think you can probably throw a picture up on the screen for those that are watching that too, of that sealed box. There is no access for any earwigs, ants, lizards, little frogs, anything that might decide to take up tenancy in the condenser. Yeah, they can't get in. They are not going to be able to destroy the contacts in the contactor. And in reality, I would use that scenario as the absolute number one reason to install a SureSwitch. Do you have to install one on every job site? No. Are you offering one every time you're replacing a contactor? I don't know. Are you offering a good, better, best scenario when you're replacing equipment? And if you are, why are you? You're allowing the homeowner to decide how nice of a system they want. And that's your same scenario that if you are replacing the contactor, why aren't you offering a good best scenario on the contactor? You have the good one, the standard one that can terminate the lives of more poor innocent insects, or you can get the SureSwitch that is going to completely seal this box and not have that issue. And on top of that, if you're using that good best scenario, you have the warranty you're going to offer with your standard contactor, more than likely 1 year maybe, and you're going to be able to offer a 10-year warranty on the SureSwitch, which I always recommend make sure you document that on your invoice so that the homeowner, if there is any issue down the road, and they can get it in their mind, hey, I got a part in that condenser with a longer warranty. Let's call the same company out.
One thing that I wanted to cover, because you mentioned applications for offering it, I want to talk about some of the built-in compressor protection that exists in this.
Mm-hmm.
And some of it may be redundant, but a lot of it is actually very beneficial. And one of the things that I always cover, but really two things here. We do surge protection on pretty much every application, especially in our market. We get a lot of transient voltages that can damage equipment. But surge protection does not deal with brownout. So that's one huge area. This deals with brownout. When line voltage drops, it's going to help protect the compressor. But the other thing that I wanted to mention, and I'm going to let you talk too about all this, but one of the things that I found is the reason why we've actually implemented it fully in Kalos is because one of the main times that we replace contactors is when we install compressors or we do other major repairs.
Mm-hmm.
So maybe you have a hard start kit that blows up on you or something weird. You get those cases, and so we want to replace the contactor during that event. And one of the things that's really important, in the past we have replaced single phase or 1+ contactors with 2-pole. But the problem is a lot of times with certain brands, their crankcase heater configurations do not work properly when you have 2-pole contactors in place, because they actually shunt around one of the poles and actually use the compressor windings as part of that circuit. And so this solves that problem too. The reason why we always did 2-pole contactors is because they last longer. We would use the 40 amp 2-pole because they were a little bit more universal and the kind of heavy
Mm-hmm.
duty. But this really solves that problem because now it solves the longevity issue, it solves the multi-voltage issue, and it also eliminates the problem of you having to do something weird to kind of work around a 2-pole, because for the longest time we only stocked 2-pole contactors on the trucks. So yeah, so I want you to comment on that. Obviously, we've got a couple different compressor protecting features there. What are you seeing that people really appreciate?
So one of the major things really for protection is that brownout. The amount of voltage present, it's we're talking 220 to 240 volts that are constantly going to the contact points, which are underneath this little sticker for those of you who are watching. And within this, you have two legs. The one side is line, the other side is comp. So with that, you can see comp or compressor, and the line side here is where that 220, 240 volts goes in. And inside the processor, it is monitoring that voltage. When that voltage drops below 184 volts, the control will recognize that and open the contact points. So we cannot do the damage to the compressor. Well, how does that work? What are we talking about when we're dropping low voltage? What happens? Well, when you drop your voltage, you raise your amperage, you raise the amount of heat that's being generated in those windings. And when you're raising the heat level for a long period of time, you are actually having the potential to melt the materials that are holding those wires together in the windings of the motor to the point that the windings will short out and you'll lose the compressor, you'll lose the condenser fan motor. So that's your basic scenario of what's going on with that. And so what we do is we monitor that, look for that voltage, and if we're dropping for more than 4 seconds below 184 volts, we are opening the contact points. We're not allowing damage to the system. We wait for that voltage to climb up above 190 volts for more than 10 seconds, and then we will close back. So it's not like it's out and there's a reset. It's an automatic turn back on once the voltage comes back into place. The other point that I want to make with the SureSwitch is that this SureSwitch, the bottom has this little writing on the base, and the SureSwitch has 4 bolts. These 4 bolts, if I get the right angle here for you to see them, they're in the 4 corners of not corners, but the 4 corners of the upper part of the SureSwitch. Maybe I should say that. So you can see a straight-on shot here. The fact that they aren't centered, they aren't specifically on all 4 corners. One of these screws is tightened from the factory, the other 3 are loose. So if you buy your first SureSwitch and you say, oh, I got one that was returned because somebody's already been in this, only 1 screw was down. No, we only tighten 1 screw from the factory because we know that the top and the bottom are going to have to be separated to be pulled apart so that the bottom piece can be mounted, and the mounting holes are identical to the spots of the mounting holes of a standard contactor, so we're not having to drill new holes to mount this. But now comes the question of these 4 screws. Where are you mounting? Which direction are you mounting the SureSwitch? All of 4 wires come out of one side. I've yet to have an application where you can't stretch or pull wires without a wire stretcher, by the way. We never
Indeed.
bought those.
Yeah,
Our service vans never had them on them. We just did not find a need for wire stretchers, and we could stretch the wires around to the one side. And with that, when you're mounting the base, how do you know with the screw holes? How do you know where to put this or which way to mount the base piece? Well, there's writing here. The line and compressor writing in the base is the same side as where the lugs are. So when you have it apart, you don't have to try to match it back up together and say, okay, this goes with this side, and so we need to mount it this direction or upside down, however we're going to mount it, because it can be mounted in any direction. Just look at the base, see in the molding where it says compressor and line, and you know that's the end where the wires are going to go. So a little tech tip there to connect it. Back to our brownout protection, the voltage going in this side, you can see, for those of you who are looking at the video portion, the middle two are just simply a shunt or a jumper. So your crankcase heater is actually going on the outside two lugs. They are going between where the contact points are opening and closing. That way, when the contactor is closed, these 2 points are the same leg, and you are not going to have your resistance on that crankcase heater. When they're open, that's where you're bleeding through or pulling through from the other leg to the crankcase heater to get that power.
Yeah, and that's, if anything, with the SureSwitch that you just have to provide some training is to your techs, because it looks different, right? Like, that's all it is. It's not, rather than having kind of top to bottom, now you're working more side to side in one row. And it doesn't take rocket surgery to train it. It's just a little bit different. And so there is a little bit of training to do that. And we're going to be releasing some illustrations that kind of show some of the basics of replacing one with the other and all that. Or my good friend JD Kelly over at Student of HVAC has done some illustrations for us. So we're going to release some of those as well, just to make it super simple, along with the obviously the information from Copeland is always really great as well.
Yeah, and I agree. There's just not a lot of rocket surgery to do out there. As a matter of fact, I don't know. You're down there in Florida, close to NASA. Have you ever met a rocket surgeon yet?
Yeah, you got to catch them at the bar over in the Cape, because it's highly restricted, and sometimes they'll reveal their rocket surgery badge to you, but it is rare.
Yeah, if you are a technician right now and you are at the college for rocket surgery, I would say you do not have to finish that course, because you can install the SureSwitch without a degree in rocket surgery.
Indeed. Talk about the random start delay, because that is very interesting, and especially applies to cases where you have multiple units on one house.
Very good. Multiple units on one house, or an apartment complex where we're talking about a whole row of condensers. And one of the features is what we call the blackout random start delay. Well, what's a blackout? A blackout is just simply the loss of 220, 240 volts. That can occur from the power company. It can occur from the electric pole that was just mowed off down the street, or it could be when the tune-up technician is out there cleaning the outdoor coil and they have removed the contact or the disconnect piece out of the disconnect and blacked out that SureSwitch. Anytime there is a blackout scenario, when the power is re-energized, if there is an immediate call for those contact points to be energized at the time that the power is restored, they are not going to all instantly kick on. We have set a random 0 to 90 seconds for those contact points to energize. So if you have a large house or an apartment complex, the power does go out, and on the whole complex, while there is calls for cooling, when that power is restored, you do not have 3, 4, 5, 10 compressors all kicking on at the same time and making that meter jump through some pretty major amp draws. They randomly come on between 0 and 90 seconds, and so now you are spacing out those timings and allowing for less of a instant pull or draw when electric is restored. The power company says thank you too, because they have to put a surge out there to, when they restore power, to get all of those motors that are going to instantly come on enough power to do that. And by doing the random start, you're lightening that load from the electric company as well.
Yeah, absolutely. One of the other things that's built in is a short cycle timer. And I think one of the things that a lot of techs think, I know I thought it when I first read this, I was like, well, yeah, but don't you already have a short cycle timer in the thermostat? True, but a lot of times it's the thermostat that's causing the problem, right?
Mm-hmm.
Like, again, this is going to protect for that. Now, again, there's a lot of different reasons this can happen. But if you have, for some reason, a system that's trying to, re-energize within 3 minutes, this is going to catch it and prevent that from happening. Regardless of the reason that happens. Obviously, in the age of mercury bulb thermostats, for those of you who are old enough to have worked on those, like Jim and I definitely did. That was a huge problem. But nowadays, you still do run into cases where that can happen. And one of the ones that I definitely ran into in a few cases was jiggling the float switch, and for whatever reason, the thermostat didn't catch it. And now we actually ran into a case, and these were not Copeland compressors that this happened to. I want to be very clear, but a couple manufacturers' compressors started running backwards because of that rapid short cycling. And this would have prevented that, because this would have caught it and made sure that it waited 3 minutes before kicking back on.
Absolutely. Yeah, and so with that, you do have that timer, and so the next comment is, well, wait a minute, I got a timer on my thermostat, and now I got a timer on the SureSwitch as well. I got to wait for my thermostat timer to go through and then send power to the SureSwitch, and now I got to wait another 3 minutes. And I would like to rob that thought from you, because the timer for the SureSwitch starts when the contact point's open. So when you're done with your thermostat timer, you've already passed the 3 minutes timer on the SureSwitch, and you're going to, when the thermostat sends that signal, it's going to instantly kick on. So you're not doubling your amount of wait time for that system to kick back in. The SureSwitch will have done its countdown while the thermostat was doing it, and then you aren't even going to see that feature really being used in the SureSwitch. The only time you're going to see that is when you have that glitch of power, just enough to break things, and with the SureSwitch, that's going to help eliminate that.
Yep, absolutely. And as much as I would love to keep talking about the SureSwitch, we are out of time. So I want to remind everybody to find out more. You can go to hvacrschool.com/SureSwitch, hvacrschool.com/SureSwitch, or you can just go to the Copeland website, copeland.com, and you can find it there, obviously. Any other resources or anything you would want to plug here?
The WR mobile app is a great app on your phone that you can put in your old contactor number, or you can just simply put in the SureSwitch part number. And within that, you can have all your spec sheets. You can see all the data readily available in WR Mobile, as well as a installation video that we go through in installing the SureSwitch. And actually, we have two videos: one for a refrigeration installation, and one for a residential AC installation. And not only can you access our installation videos, but Bryan also has a really nice installation video out there on HVAC School that you can access that video on through him as well, or his version. And his version probably is a lot more fun to watch.
All right, so WR mobile app, Copeland.com, hvacrschool.com/SureSwitch to find out more. Ask for SureSwitch from a wholesaler near you. If they don't have it on the shelf, they can easily get it. Copeland and White Rogers are everywhere. Jim, thank you as always for the time you take teaching the industry, and it's always really, really appreciated, the detail that you bring to these podcasts. Even though sometimes we do chatter, we can be confident that the SureSwitch will not.
Yeah, well, you gotta make sure all the volts are present, and sometimes the some people may be a couple of French fries shy of a Happy Meal, but some of us maybe a few volts short of a full contactor. So, yeah.
All right. Thanks, Jim, as always.
Hey, my pleasure. Good to chat, Bryan.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.